Hello and welcome to the problem set 5, problem 3 solution video. And I've done a little pre-cooking in this problem set just because there's so many boxes to make. And so this first problem asks me to build a 16:1 mux, which I have built here, from two 2:1 muxes, two 4:1 muxes, and one 8:1 mux. And so my first inclination is to think, well, I've got this 8:1 mux, and it's probably going to be easier to use that either here at the very beginning and have it cover those, or have it here at the end. And since one 8:1 and two 4:1s kind of are similar, I'm going to stick with the 8:1 over here. So I'm going to put that up here with these bits here. That's going to cover those down to 7. So I have my 8:1 mux, input 0, 1, 2, 3, 4, 5, 6, and 7. The select bits S2, S1, and S0. And I'm just going to connect these like so. So this output now is going to be taking into account the 3 lower significant bits, S2, S1, S0, because all these minterms here have 0 for what would be this S3 select bit. So I'm going to put S2, S1, S0 into each of these. And now for 8 through 15, I'm going to want to use my two 4:1s just kind of to keep some symmetry here. So that'll fit in there. This one will fit in here. I got a 4:1 mux with 0, 1, 2, 3, S1, S0, 4:1 mux, S1, S0, 0, 1, 2, 3. So I'll put these 3 together, these 4 together, sorry, should be 4 in both cases. And here, 8, 9, 10, 11 all share a 1, 0 to start their minterms, and these all start with 1, 1. So I'm going to eventually want to distinguish these two by their S2s, but each of these can be selected from S1, S0, S1, S0, and I'm going to want to take this output and put it into a 2:1 mux. That'll distinguish based on S2. So this is S0, gets S2, 4:1 mux, 0, 1. And so essentially what's happened here is I've basically created another 8:1 mux out of my two 4:1s and my one 2:1 mux. And now I just need to get one output. So I'm going to need to put these together. And so this is one 8:1, this is one 8:1, distinguished by their S3. I'm going to put these into one final 2:1 mux, 2:1 mux, 0, 1, S0, select bit S3. We'll distinguish between this set of minterms, that set of minterms, and our output. And that finishes part A. And for part B, we have a 3 to 8 decoder. And I've kind of drawn my box again, and I'm going to have most significant bit down to enable, and I need to build it with the largest decoder I can use as a 2 to 4 with enable. So here I'm not told exactly which ones specifically which ones they all need, but I'm pretty certain I'm going to want my at least two 4:1s on this side, so I can have one 4:1 taking care of this, and one 2 to 4 taking care of this, and one 2 to 4 taking care of this. So I'll put my 2 to 4 decoder in. 2 to 4 decoder, and I'll have 2, 1, and enable, and 0, 1, 2, 3. 2 to 4 decoder, 0, 1, 2, 3, 2, 1, enable. And so, the first question I want to figure out is what should my inputs to here. And since these all share the most significant bit in common, I'm not going to want to put 4 in. I'm going to want 2 and 1 onto these. So that's going to come into there, that's going to come into there, and similarly these will go into there. Now I just need to figure out how to enable them. And to do that, I'm going to need another encoder over here. I only have one extra bit here. I'm going to have to take that enable into consideration, and another decoder is going to enable or disable these. So simply, I will just put a 1 to 2 because I only really have one input. So this will be 1 with enable. And this will go here. And this is a 1 to 2 decoder. And it has only 0 and 1. And so this will go into there. And this will go into there. These will each go to these spots respectively. And that is my 3 to 8 decoder built from 1 to 2s and 2 to 4s with enable. For the final part, part C, it asks for you to write a solution strategy first, so I have not done the pre-cooking on this one because that is part of the solution strategy. So the first thing I want to make sure is that I know exactly what I'm building. And so for my first part of solution strategy, I expect to see that you're kind of seeing where you're going. And so for that, I'm going to need to build a box. And I'm going to want to put the box in. So 8 to 1 mux. And it's going to have inputs 0. Oh, sorry, I'm going to put those on the outside. 2, 3, 7. I'm going to cross this off really quick. I'm going to have inputs S2, S1, S0. So the next thing I notice is that saying I can only use a decoder. And kind of one of the foundational things that you should notice about the mux is that basically it uses the min terms to select which one of these inputs is coming through, basically treating the min terms as enable lines. Well, what does that sound like? Min terms, enable, that's a decoder. And lucky for us, it says using only decoders, 2 input AND gates, and 1 OR gate. Well, decoder, you have min-term generator. AND gate, you have an enable, a disable switch, essentially. And the OR gate, I can put all those things together at the end. And so, this, simply put, this problem comes out to be, we're just going to put our 3 to 8 decoder in here to basically create the min terms for S2, S1, S0. So this is going to have 4, 2, 1, and I don't really need an enable because this is not a mux with enable. And so I have 0, 1, 2, 3, 4, 5, 6, 7, and these are my min terms. I'm going to actually label these I0, I1, I2. Like that. And then so this min term corresponds to I0, and so when this is 1, we want to enable it. Sorry, I need to put the S1, S0s there. So when the min term is 0, I want to enable I0 to come out. So I0 goes in there. I1 goes in here. I2 goes in there. I3 goes in there. I4 goes in there. I5 goes in here. And then I7 goes into there. And then since I can only have one output on the mux, I'm just going to need one gigantic OR gate to put those all together. And that completes my 8 to 1 mux.